Please begin your warm-up. I'm going to do 1 as an example, and then you'll complete the remaining. Negative 1/3 times negative 1/3 times negative 1/3. 1 times 1 times 1 is 1. 3 times 3 times 3 is 27. A negative times a negative makes a positive. But then if we multiply by another negative, that gives us negative 1 over 27. Complete the other 5, and then go ahead and move on. In this, we are going to change the number of tiles. So let's say we want 6 tiles, or maybe we want to make it a square, so it's a perfect square, and there would be 6. So 6 squared is 36. If we made it 5, you can see 5 squared is 25 because it's a 5 by 5 square. 4 squared is 16, and we can play around with how many we need. 7 squared is 49. In the cubes, if we wanted a 2 by 2 by 2, we would have 4 across the bottom, but we need to fill in the second row as well, giving us 8. So 2 cubed requires 8. We could change it to a 4 base, so the bottom would need 16 for 4 by 4, but then we need 4 rows tall, which would take us all the way to 64. There we go. So 4 by 4 by 4. We can do the same thing. 5 by 5 by 5 should be 125. Use what you know about the area of a square to complete the table. So 1 squared, 1 times 1 is 1. 2 squared, that's 2 times 2. 3 squared, 3 times 3 is 9. A lot of times people get confused and they want to say that is 6. That is not true. If you aren't sure, rewrite 3 squared as 3 times 3. So 4 squared would be 4 times 4, giving us 16. 2. Suppose a square has an area of 25 square units. What is its side length? Explain how you know. Well, 25 is 5 times 5. So the side length must be 5 units. And we know this because 5 times 5 is 25. In order for it to be a square, both of these numbers have to be the same. So we couldn't do like 10 times 2.5 because those are not the same numbers. We need to use 2 of the same numbers because it's a square. Three, use what you know about volume of a cube to complete the table. So we're doing 1 cubed. 1 times 1 times 1. 2 cubed. 2 times 2 times 2. A lot of times people want to say that this is 6, but this is 2 times 2 is 4, times 2 is 8. 3 times 3 times 3. This would make 9, and 9 times 3 is 27. 4 cubed, that's 4 times 4 times 4. This would be 16, and 16 times 4 is 64. 4. Suppose a cube has a volume of 125 cubic units. What is the edge length? And explain how you know. The edge length would be 5, because 5 times 5 is 25, and if we multiply by another 5, that gives us 125. In this Venn diagram, we're going to sort them into perfect squares, perfect cubes, both, and neither. All right, so 50. Do any two numbers multiply together, any two whole numbers multiply together to make 50? I know 7 times 7 is 49, but the next one would be 8 times 8, which is 64. So 50 falls into the neither category. 121. 10 times 10 is 100. 11 times 11 is 121, so that's a perfect square. 64. Well, I know 8 times 8 is 64, so that could be a perfect square. But we also saw that 4 times 4 times 4 makes 64, so that is a perfect cube and a perfect square. 81 over 100. Now, 81 can be formed by 9 times 9, and 100 can be formed by 10 times 10. But since it's a fraction, this is a neither, because we would have 9/10, but that's not a whole number. Perfect squares and perfect cubes must use whole numbers. 0. Well, I know 0 times 0 is 0, so it's a perfect square. And 0 times 0 is 0, so it's also a perfect cube. 0.027. Well, I know 3 times 3 times 3 is 27, but because it's a decimal, we're not going to be able to use whole numbers to get a perfect square or a perfect cube. -64. Well, -8 times -8 would be +64, not -64. So it's not a perfect square. But we did also say it was a perfect cube. 64 was a perfect cube. Let's see if -4 times -4 times -4. This would make +16, and +16 times -4 would be -64. So that is a perfect cube, but not a perfect square. 1 times 1 is 1, so it's a perfect square. 1 times 1 times 1 is 1, so that is a perfect cube. For problems 6 through 9, evaluate. That means figure out what it's equal to. 5 squared is 25, and 8 squared, that's 8 times 8, is 64. -1.1 squared, that'd be -1.1 times -1.1. This would be 1. 1 times 1 is 1. Then we would put our place value spacer. 1 times 1 is 1. 1 times 1 is 1. Add them up. We have 2 decimal places in the question, so we need 2 decimal spots in our answer. A negative times a negative makes a positive, so this is positive 1.21. We also know that 11 times 11 is 121, so 1.1 times 1.1 would be 1.21 instead of 121. 3 cubed, that's 3 times 3 times 3, or 9 times 3, which is 27, and 4 times 4 times 4, or 16 times 4, which is 64. And number 9. Well, I know 2 times 2 times 2 is 8, so 0.2 times 0.2 times 0.2 has to have some form of an 8 in there. But there are 1, 2, 3 decimals in the question, so we need 1, 2, 3 in our answer. Remember that we said 81 over 100 was not a perfect square or a perfect cube because it's not going to have a whole number answer or an integer value that can square to make 81 over 100. But we did say that 81 can be formed by 9 times 9, and 100 can be formed by 10 times 10. So this is 9/10 squared. But that's not the only way we can get 81 over 100. Here you can see that -9 times -9 is also 81, because remember, two negatives multiplied together make a positive. And then 10 times 10 would make positive 100. So -9/10 squared also gives us 81 over 100, because this negative fraction times another negative fraction would give us a positive. So what are all the numbers that square to make 49 over 100? Well, 49 is 7 times 7, and 100 is 10 times 10. So this is one of them. Or we could have -7/10 as well, because -7 times -7 would make positive 49. In a cube scenario, to get a negative, all three of the numbers have to be negative. So 1 times 1 times 1 makes 1, and 3 times 3 times 3 makes 27. But it needs to be -1/3. If we used positive 1/3, a positive times a positive times a positive would give us positive 1 over 27, but not -1 over 27. So in the cubes, with a negative, there's only one possible answer. What are all the numbers that square to make 1.69? 13 times 13, that'd be 3 times 3 is 9, 3 times 1 is 3, then we use that place value spacer. 1 times 3 is 3, 1 times 1 is 1. But that's 13. So in order to get 1.69 instead of 169, we would use 1.3. In the square scenario, a negative times a negative also makes a positive. So we can have positive 1.3 or negative 1.3. We knew 5 times 5 times 5 made 125, but we want 0.125, so we want 0.5, 0.5, and 0.5. If we use positive 0.5, that's going to give us positive 0.125. So we need all of these to be negative. And we can't have a mix of the two. In a cube scenario, all of them are going to either be negative or all of them will be positive. We can't mix them up. So the only option here is negative 0.5. Make sure your warm-up is complete and your workbook is filled in, and that's it.